All right, today what we're looking at is landscape characteristics. All right, so landscapes kind of describes the shape of the land, and there's a variety of things that you can study when you're looking at the shape of the land. One thing you might describe is, like let's say I was buying a piece of property, I wanted to describe the land to someone. One thing I might describe are whether my piece of land is like hilly or flat. And if I was going to describe the hills, things that I might use to describe it, I might talk about how steep the hills are. All right, some hills maybe, all right, because like these two hills right here, all right, they're both the same height, but this one's steeper than that one. So gradient or slope might be a thing I use to describe it. Another thing would be the height, all right? So along the same line, these guys here have about the same slope, but what's different about them is they have different heights, all right? And another thing that you might use to describe the hills is the shape, all right? I might have one hill that has a shape like that, and I might have another hill that has a shape like that, all right? Now, they're both the same height, and if I was going to calculate their gradient or their slope, gradients like rise over run, so the height divided by the distance, well, the height of both these is about the same, and the distance for both those are about the same. So they both have about the same height and they both have about the same average gradient, but by looking at them, you can tell that the shape of them is different. One of them has a convex shape, one of them has a concave shape. All right, so describing the hills is one thing I might do to describe a piece of land. Another thing I might talk about is the soil. What kind of soil do I have in that piece of land? All right. Now, things that help determine the soil, one is the bedrock, all right? With residual soils, which are soils that form in place, it comes from the bedrock. The bedrock weathers and breaks into smaller pieces. So the soil comes from, most of the soil comes from the bedrock if you have a residual soil. So whatever the composition of the bedrock is, that's largely going to be the composition of the soil if I have a residual soil. All right. Another thing that can affect the soil are plants, all right? Plants have roots, and roots get in there and help break the rock apart. So plants help make soil. Also, when the plants die, their plant remains become the organic matter in the soil. So plants help determine the soil, but the type of soil also determines what kind of plants you have too. Like some plants like soil that's acidic. So if I have acidic soil, that's going to help grow plants that like that kind of soil. When the plants die, they're going to help make the soil again. So that's why that arrow there goes both ways. So the plants help determine the soil, but the soil can also help determine what kind of plants you have too. Another thing I might describe a piece of land by is the drainage or the streams that are on the land, all right? So if there is a stream on my piece of property, and if I want to describe that stream to someone, some of the things I might use to describe that stream, I might talk about the size of the stream, how deep is it or how wide it is. So if it's a real, like let's say I have a herd of cows, if the stream on my property is a real shallow stream, then I might not have to have a bridge for them. The cows can walk across the creek very easily. If it's a very, very deep stream or a very deep and wide stream, then I might have to have a bridge or something built for the cows so they can go over the water. Right? So the size of the stream is one thing. Another thing I might describe about a stream is the slope or how steep it is. If the land's pretty flat, there's a good chance the stream's going to zigzag back and forth, or meander is the word we use for that. If the land's steeper, then the water's more likely going to go in a straight path. Now, the reason why it goes more in a straight path when it's steep and it tends to meander more when it's going slow It has to do with the velocity. When the water is going slow, it has a tendency to kind of go back and forth. When the water is going fast, it's more of a straight line thing. Okay. So size and slope are two things you can use to describe a stream. Now those are the two that are probably most familiar with, to you. Some of the other properties you might use to describe streams is something called their drainage density. All right. Now, this is not a bush and a tree. These represent two drainage systems. All right. So here's a drainage system representing about that much area. Here's another drainage system averaging about that same amount of area right there. All right. Now, what I'll notice is that in this area, there is far fewer miles of streams than there are in this area. So if I were to add up all the miles of streams that were here, and I were to add up all the miles that were streams here, what I would find out is there's many more miles of streams in this area than there is in this area. So there's more streams per square mile. So that would be an example of something that has a high drainage density. This would be an example of something that has a low drainage density. All right. Now, it might be like, oh, what's the big deal about that? Well, looking at a map and seeing the streams, whether they have high density or low density, can tell us a lot of information about what the ground underneath it's like. Now, assuming these two areas get about the same amount of rainfall, if there is a lot of stream channels, what that means is that when it rains, the water is not soaking in the ground very much, right? Because most of the water is staying at the surface to make stream channels. Where with that same amount of rain, if you don't have very many stream channels, what that likely means is more of the water soaking into the ground. So if there's a low drainage density, that likely means that the ground is highly permeable. More of the water soaks into the ground. If I have a high drainage density and lots of stream channels, what that's more likely going to mean is that the ground has a low permeability, meaning that the water does not soak in the ground very easily. So when it rains, not much soaks in, more of it flows off, and as a result, you're going to have more stream channels. Here, if the ground is permeable, it rains, most of the water is soaking in, you're not getting as much flowing across the surface, and as a result, you're getting fewer stream channels. All right, now, take that a step farther, I can make inferences about what kind of rock is underneath it based on whether I have a high drainage density or low drainage density. Now, most of the rock at the Earth's surface is sedimentary. All right, there are places where it's igneous or metamorphic, but most of the rock at the Earth's surface is sedimentary. And of all the types of sedimentary, there's three that are the most common. All right, shale, sandstone, and limestone are by far the most common of the sedimentary rocks. All right. Now, sandstone is typically a more porous rock. All right, sandstone typically lets water soak through it more easily. So if I see a low drainage density, that probably means the water is soaking in the ground pretty easily, and the type of rock that lets water soak into it is sandstone. So if I have a low drainage density, the inference I can draw from that is that the bedrock sandstone. If I have a high drainage density, that means the water is not soaking into the ground. The type of rock that has the smallest particles and therefore the smallest permeability of the common sedimentary rocks would be shale. Water does not pass through shale very easily. So if I see that there is a high drainage density, that means not much water soaking in the ground, and the type of sedimentary rock that doesn't let water soak into it very easily is shale. So if I see a high drainage density, an inference I can draw from that is that the bedrock must be shale, right? It might not be, but that's a logical inference to draw, and the same thing here. It might not be sandstone, it might be something else, but there's a good chance that it is sandstone. Okay? So drainage density is another thing I might use to describe a stream. Right? Another thing I can use to describe an area of streams is the drainage patterns. Right? Now the drainage patterns are significant because drainage patterns, if I see those on a map, that tells me a lot about what the underlying bedrock structure is like. So we're going to focus on four drainage patterns. All right. The first drainage pattern is like the one that I drew up here. All right. That's called random or dendritic. All right. Random or dendritic. That's the kind of drainage that you're going to get if the bedrock is flat. So if I had like an area and all the bedrock layers were flat and the land was kind of flat, I'd get the kind of drainage that looks like a tree. So a dendritic pattern is the one that looks like a tree. That's usually the result of horizontal rock layers. All right. So when I see that kind of drainage pattern, I know the rock layers are probably flat. The next kind of drainage is something called trellis or block drainage. And what I have here are a bunch of parallel channels, all right? A bunch of parallel streams with maybe a few connector channels to it. What might cause that is if I had some rocks where I had some folds in the rocks and right, so the land kind of looks like that with the streams going down the middle like that. So these streams kind of going between the hills cause these parallel hills like that. And I can show you a block model that kind of shows that. All right, here, so I have rock layers that have folding in them, all right? And then if I look at my thing here, I have a bunch of parallel kind of valleys, all right? So those parallel valleys would have streams in them. And I have a bunch of parallel streams. So I have something that kind of looks like that. So trellis or block drainage is frequently caused by folded bedrock, all right? With the areas, low areas between the folds being where you have streams. You can also get it with faulting too sometimes. All right, so that's trellis drainage. Right. Next kind of drainage, radial drainage. All right, with radial drainage, what you have are a bunch of streams flowing away from the center. So the high point is going to be in the middle. Now, where I would typically get radial drainage would be around something like a volcano, all right? Because here's the high point right there. If it's raining, the rain's going to fall and it's going to kind of flow down the sides away from the high point. So a top view of this might look like the streams are flowing that way and the streams flowing that way and the streams flowing that way and the streams flowing that way. All the streams are flowing or radiating away from the high point. That's the kind of drainage you get with radial, is what you get around like a volcano. Sometimes it'll be a volcano, sometimes it's called a feature called a dome, which is kind of like where the, it's kind of shaped like a volcano, but the magma didn't bust out the top, so it doesn't have like a crater on it, but the shape of it's kind of like that. All right. That's radial drainage. The last one here is annular drainage, and this is the one that's kind of hardest to describe. Annular drainage is kind of like if we had something like a volcano where you had magma coming up underneath it, and I had something like that, but then the top of that eroded away. And the best example I have of that is this guy right here. So here's where the magma came up. So there was something there at one point, but then erosion chopped it away. And I left a feature here that has a bunch of round things like that, all right? Now what can happen is streams will flow in those round sections right there. And that's how I get annular drainage, rings. So I get that when I have a dome or a volcano where the top of that has eroded away, and that's going to leave it a round type feature that can have streams in it. All right. So those are the four main types of drainage patterns that you need to be familiar with. All right. Now, using a combination of the shape of the bedrock and the shape of the land, we've come up with three landscapes that we use to describe the land. Right? Mountains, plateaus, and plains. Right? Mountains, plateaus, and plains. Now, start off with mountains. You know, typically you think of a mountain as something that has high elevation, and most mountains do have high elevation. But just the fact that it's high in elevation does not necessarily make it a mountain. There's other things that make it a mountain as well. All right? So some of the characteristics of a mountain is it does have high elevation, but what mountains also have is they have deformed strata. All right? Deformed strata. Now, if you remember what strata means, strata is the horizontal sedimentary rock layers. Whenever you see them not horizontal, that means they've been deformed somehow. Now, for mountains to form, there's a variety of ways in which they can be deformed. So like right there is an example of folding. I have high elevation and the rock layers are folded, so they're deformed. So that could qualify as a mountain. Or another thing that can happen is the rock layers may fault and one section gets pushed up that way. Again, the fault shows you someplace where the rocks would have been deformed, right? So with a fault type mountain, I might have something where the rock layers are like that, where one of them kind of went up like that to form the mountain. So the fault's the thing that deforms them. Or another thing may have been something along the line with the volcanic mountain, where the magma coming up kind of pushes the rock layers up, and the magma comes up and pushes the rock layers up and deforms it. But somehow the rock layers, they're not in horizontal lines, they're deformed somehow. And mountains have high relief. What high relief means is that there's like a big difference between the top and the bottom, so it's going up and down quite a bit. Plateaus. Right? Horizontal strata, all right? Plateaus have horizontal strata. Their elevations are typically high, medium to high elevations, usually not as high as mountains, but they can be fairly high in elevation, so I'll say medium to high. Medium relief, in other words, it doesn't go up and down as much. Now, a lot of times people get plateaus and mountains mixed up. Because like with these two guys right there, if I was someone walking on the surface of that, and I was someone walking on the surface of that, you know, there might be the same elevation and the slope might be the same. You know, they might seem from the surface quite identical. And a lot of times people call plateaus, dissected plateaus, mountains when the rock layers are horizontal. So technically they're not mountains. So the reason why one's a mountain and one's another has to do with the processes that make them. All right. The reason why this has that shape is because there were rock layers like this, and the rock layers bent up like this. The rock layers were pushed up to make that high in elevation, all right, and create that shape. Now with a plateau like that, even though the surface of the rock looks the same, the difference about this is the reason why this has the shape is the rocks used to be like that, but then either like a river or a glacier or something right here was eroding the rocks away, all right? So something was eroding the rocks away. So the reason why this feature has the shape it does is because erosion eroded those parts away. Not because this part here got pushed up necessarily, but this part here eroded down. That's why it has that shape, right? And if it's eroded quite a bit like that, it's called a dissected plateau, and those especially look like mountains from the surface. And again, there's a lot of places on the earth where we have things that are technically plateaus, but people call them mountains. And I'll show you a famous example of that in a minute. All right, so key thing with plateaus, Plateaus have horizontal rock layers. Plateaus have horizontal rock layers. All right. Last one here, plains. Plains are kind of, well, plains, horizontal strata, low relief. So in other words, the rock layers are flat and the surface is flat. So over here, this would be kind of like the landscape you'd expect to see with a plain. Horizontal rock layers for the most part, and the surface of the land is pretty flat, so that'd be a plain. All right. All right. Now, in your reference tables, there's a chart that shows you the landscapes of New York. And it's on page 2. All right, so here's New York State here. So some of the main landscape regions, you got the Allegheny Plateau, Erie Ontario Lowlands, which is a plain, Tug Hill Plateau, Adirondack Mountains, St. Lawrence Lowlands. Lowlands and plains are the same thing. Taconic Mountains, Atlantic Coastal Plain. The Manhattan Prong is part of the Taconic Mountains. Now, a famous example where people have made a misnomer, where they misnamed something, the Catskills. People usually call the Catskill Mountains, but in the Catskills, the rock layers are horizontal. The Catskills technically aren't mountains. The Catskills are part of the Allegheny Plateau over here. Okay. Now, what these lines on the graph on this map mean, the solid line means I'm going from one landscape region to another. So like right here, I'm going from the plains to the plateau when I go from there to there. And anyone who's ever traveled, say from like Seneca Falls or Geneva, and you're going towards like Ithaca or Watkins Glen, at the north end of the lake by Geneva, Seneca Falls, it's pretty flat. But when you go to the south end of the Finger Lakes, it's very, very hilly down here because it's a plateau as opposed to a plain. All right. Now, another thing you'll notice on here, you see that dotted line says landscape region boundary. What that means is basically the name's changing, but it's geologically the same. So here's the Allegheny Plateau, there's the Catskills. Geologically, these two things are the same, but the name just changes from one place to another, so it has that symbol right there. Same thing here, you got the Erie, Ontario Lowlands here, and I got the St. Lawrence Lowlands right there. You see it's divided by the little dotted line. What that means is geologically this and this are the same, but that's just where the name changes right there. Same thing with the Champlain Lowlands. I see that little line right there. So geologically this and this are pretty much the same. It just changes name. So the dot means geologically it's basically the same, but it changes name. The dash 2 dots is just the state boundary, all right? So that line there does not really hold any significance geologically speaking. That just separates New York from Pennsylvania. That just separates New York from Vermont, New York from Massachusetts, New York from Connecticut. The next line here, international border, a line with 3 dashes. So right there, that line here just shows us what the border is between New York, the United States, and Canada. All right. Now, the questions that you normally get with this chart here is usually in conjunction with the other chart of New York State you have in your reference table. So a question you might get is like, most of the rocks in the Allegheny Plateau are from what time period? All right, so first off, I gotta find the Allegheny Plateau right here. then to answer that question, I would have to go to the other map in New York I have right here. And I can see that's where the Allegheny Plateau is. I come down here to the little dots. Most of the rock in the Allegheny Plateau is from the Devonian time period, all right? Or another question I could get. I might get a question like, where is most of the metamorphic rock in New York State located, all right? So if I look in here, nicest quartzite marbles are the squiggly symbols. I see most of the squiggly symbols right there are located in the Adirondack Mountains. Right? Another possible question, like at, let's say 42 degrees north, 78 degrees west, what landscape region is that? Well, there's 42 degrees north right there, 78 degrees west is right there, so 42 degrees north, 78 degrees west is going to put me right there. Then if I wanted to see what landscape region that is, I'd go right there, and that's the Allegheny Plateau. All right. So those are typically the kind of questions that you'll get using that chart. It's usually using that in conjunction with using this other chart here, which we've used before. All right. So that is landscapes and the landscape regions of New York.